Assalamualaikum warahmatullahi wabarakatuh and very good day. So for part number 2, for chapter number 1, we will discuss about system, properties and processes involved in thermodynamics. Okay, now we want to know what is the meaning of the system, boundary and also the surroundings in thermodynamics. So this schematic diagram shows the general system, and this is the cylinder piston device where we will consider as our thermodynamic system, and we will use these two figures to explain what is the meaning of the system, boundary and also the surrounding. Okay, system in terms of definition is quantity of matters or a region in space chosen for study. So the system is the area or the region that we use to study about the thermodynamic process. Okay, and then the blue color area represent the surrounding, okay, the system surrounding, where the meaning of surrounding is mass or region outside the system. However, the boundary of the system is the real or imaginary surface that separates the system from its surroundings. So the boundary represented by the red dotted line in this figure. So for boundary, actually you can choose your own boundary to study. Normally as a guide we will choose the wall of the device as the boundary of the system. For example, this schematic diagram shows the basic features of a turbine, where we have a wall, inner turbine wall. So in order to select the boundary, we can select the wall as our boundary. Okay, the closest, the boundary that very close to the wall. And there are two types of boundary, as mentioned in the definition of the boundary. So we have real and also imaginary surface that separate the system. Okay, so when we select the boundary, so whatever inside our boundary we consider as our system. And the boundary that we choose based on the wall we consider as the real boundary, and the other one we consider as the imaginary boundary, where we not refer the wall as our reference for selecting the boundary. Okay, so these are the definition of system, boundary and also the surrounding. Okay, for the system, as I mentioned before, so the system actually the quantity of matter or a region in space chosen for study. So there are two types of system in thermodynamics. First, we have a closed system. The second one, we have the open system. Okay, for closed system, for example, the figure shows, this schematic diagram shows the example of a closed system. Okay, so we have cylinder, we have a piston, and we select the boundary for our system. Okay, so this system also we call control mass system. Closed system actually is a system that consists of a fixed amount of mass inside our system, which means any substance inside our system in terms of mass will be constant throughout the process. The main criteria for the system is no mass can cross its boundary. Okay, no mass in, no mass out, because we don't have any inlet and also any outlet for the mass to enter or exit from the system. However, for the closed system, energy in terms of heat and work can cross the boundary. So energy transfer are allowed in closed system. Okay, so energy transfer in, energy transfer out are allowed in this closed system. The volume for the closed system does not have to be fixed. For example, if the piston move upward or move downward, so the volume will change. However, the system we still consider as the closed system because the main criteria for the system is no mass in, no mass out, no mass transfer in or out across the boundary. So for closed system, which is we not allowed any energy transfer in terms of heat and also work, we will call the system as the isolated system. Okay, for example, if we have a rigid tank, so this rigid tank, we have a boundary and we consider whatever substance inside the rigid tank we consider as the system, and this rigid tank we consider as a closed system where we not allow any mass in or mass out across the boundary. However, if we also not allow any energy transfer, for example, we surrounding the rigid tank with the insulator, okay, for example, so we not allow any energy transfer or energy in terms of heat and work transfer to the system or out of the system. So this kind of system we consider as the isolated system. Okay, so this system also under the closed system. Okay, so the second type of system is the open system, and sometimes we call the open system as the control volume system. Okay, so the schematic diagram shows the example of the open system where we have inlet point and also outlet point. So the schematic represent the schematic diagram for the compressor. Okay, so we select the boundary to choose our system for study. And the open system actually is a system that involves mass flow, where mass can cross its boundary. So we will have mass in and also mass out across the boundary of our system. Both mass and energy in terms of heat and also work can cross the boundary. Okay, so we will allow mass transfer and also energy transfer in our open system. Okay, same goes to open system. The volume does not have to be fixed, so the volume can be changed to still we consider the system as the open system. So the main criteria is we allow mass in and also mass out. So these are the definition or the criteria for the closed system and also for the open system. Okay, now we discuss about the system properties, where in terms of definition, the system properties is any characteristic of a system. So there are two types of properties. First, we call intensive properties, where this type of properties independent of the mass of a system, which means if the mass of the system change, the properties doesn't change. For example, the properties like the pressure, the temperature, and also the density. The second type of properties is the extensive properties, where this kind of properties depend on the size and also the extent of the system, which means if the system in terms of size change, these properties also will change in terms of value. Okay, for example, the total volume, the total mass, and also the total momentum. Okay, now how we want to differentiate these two types of properties. Okay, let's take an example. For example, we just take a rigid tank as shown in the figure. So inside the rigid tank we have a specific substance with pressure, temperature, density, and also a volume and also the mass. So at this moment, in the same tanks, so we'll have the same pressure, temperature, density, volume, and also mass. However, if you want to differentiate these two types of properties, whether the property is intensive or extensive, so we need to divide the substance into two, for example as shown in the figure. Okay, so the substance inside the rigid tank is divided into two. So the properties that doesn't change, such as the pressure, the temperature, and also density, because although we divide into two, the same substance inside the same tank, so the pressure doesn't change. So both parts will have the same pressure, the same temperature, and also the same density. So these properties we consider as the intensive properties. However, for volume and mass, if we divide into two, first part in terms of value will have half volume and also half mass. Okay, so the volume and also the mass will be divided into two, although for the same substance inside the same tank. So these properties we consider as the extensive properties. Okay, that's how we can identify which properties is intensive and which properties is extensive. Okay, for thermodynamic, there are few parameters that always being used in our calculation. Okay, for example, the density. So for the density, we use rho symbol to represent the density, and the formula of density is rho equal to m divided by v, m for mass and v for volume, and the unit will be kilogram per meter cubic. For gas, in terms of gas density, so the density of the gas is proportional to the pressure, which means if pressure increase, the density of the gas will increase. If the pressure reduce, the density of the gas also will reduce. However, the density of the gas is proportional to 1 over T, 1 over temperature. So when the temperature increase, the density of the gas will reduce. When the temperature reduce, the density of the gas will increase. Different for liquid and solid. So for liquid and solid, in terms of density, we consider the liquid and also the solid as incompressible substance, where the density of the liquid and also the solid is not depend on the pressure. Okay, if the pressure change, the density of the liquid and also the density of the solid will not change. Okay, so the other properties that involve with density is specific volume. V equal to volume divided by mass, V divided by m, also equal to 1 divided by density. And also we have specific gravity, Sg equal to rho for specific substance divided by rho for the water. Okay, the density for the specific substance divided by the density of the water. And the last one, we have specific weight, gamma S equal to rho g, rho for density, g for gravity, acceleration. Okay, so that's what I call the criteria for the density. Okay, the other properties that normally used in the thermodynamic analysis is the temperature, T. The symbol that we use for temperature is T. And in terms of simple definition, the temperature is a measure of hotness or coldness. So based on this definition, if we know from the value of temperature, we can know how hot or how cold the substance is. Okay. Okay, let's say we have two different solid. Okay, so we have iron with 150 degrees Celsius and copper 30 degrees Celsius. So we attach both together, and surrounding of the solid we will have insulator in order to prevent any heat transfer in and also any heat transfer out from the system. Okay, so the characteristic of the heat is transferred from hot to the cold medium. So the heat from the iron, because the temperature of the iron is higher compared to copper, will transfer from the iron to the copper. Okay, so this process will occur naturally. After a certain period of time, the temperature of iron, the temperature of the copper will be the same. Okay, will be the same, and at this point no heat transfer anymore. The temperature is equal and we consider the condition as temperature equality, or we call the thermal equilibrium. Okay, based on this temperature principle, in thermodynamics we have another law that we call Zero's law. Okay, so Zero's law actually used to describe or used to define the temperature, where the Zero's law mentioned that two bodies are in equilibrium if both have the same temperature reading with the third body, which is referred to the thermometer, even if they are not in contact. Okay, so this law will explain about the temperature for the thermodynamic system. In terms of temperature scale, so for the SI unit we will use Kelvin. In terms of formula, temperature in Kelvin equal to temperature in Celsius plus 273.15. So we can use this equation to convert the temperature in Kelvin to degrees Celsius or vice versa. Okay, for English unit, we will use the Rankine unit R, where the temperature in Rankine equal to temperature in Fahrenheit plus 459.67. So this is the formula for conversion between Rankine and also Fahrenheit, temperature in Fahrenheit, degree Fahrenheit. Okay, so that's for the temperature. And the last one for the pressure, P symbol, we use P as the pressure symbol. So the pressure actually is a normal force exerted by fluid per unit area. So this is the definition for the pressure, and the pressure unit will be Newton per meter square, or we use Pascal. There are three types of pressure. First, we have absolute pressure, PABS, and this is actually the actual pressure. The second one, we have gauge pressure, P gauge, and the definition for the P gauge is the difference between P absolute and also the atmospheric pressure, P ATM. Okay, so P gauge equal to P absolute minus P ATM. And the third one is the vacuum pressure, P vac, is the pressure below the atmospheric pressure, P ATM, where P vacuum equal to P atmospheric minus P absolute. Okay, so these are three types of pressure. So in terms of pressure characteristic, later on we will discuss in detail. We want to know what is the relationship or the characteristic of in terms of pressure for the fluid pressure with the depth, the variation of pressure for gases, the fluid pressure for fluid at free surface of liquid, and also the liquid pressure on a horizontal plane. So later on, after this, we will discuss about this characteristic of the pressure. Okay, so before we discuss further, let's look at the example 1.1. So I want you to get the answer. So this is just the simple example for chapter number 1. So example 1.1, humans are most comfortable when the temperature is between 65 degree Fahrenheit and 75 degree Fahrenheit. Express this temperature limit in degrees Celsius. Convert the size of this temperature range to Kelvin, degrees Celsius, and also Rankine. Okay, so we already learned about the relationship between Kelvin and Celsius, and also Rankine and also Fahrenheit. Okay, so in this lecture note, I didn't provide any or I call the equation to convert degrees Celsius to Fahrenheit. So you need to find by yourself. Just Google in the internet, try to find the formula for in order to convert degrees Celsius to Fahrenheit or vice versa. Okay. Okay, now let me look at example 1.2. Okay, example 1.2. A tank is filled with oil. A tank is filled with oil whose density is 850 kg per meter cubic. If the volume of the tank is 2 meter cubic, determine the amount of mass in the tank. Okay, this is the tank. So the volume already given 2 meter cubic. The density also already given 850 kg per meter cubic. and you need to determine the mass of the substance inside the tank. Okay, so in order to solve, you need to refer to the formula that involves this volume, density, and also mass. So you need to rearrange the equation, and then you can obtain the value of mass of the substance inside the tank. Okay. Try to get the answer. Okay, now we discuss about the pressure characteristics. Okay, so first, the relationship between fluid pressure and also the depth of the fluid. So fluid pressure will increase with depth. So if the fluid depth increase, the pressure also will increase. Okay, for example, we have what we call free surface liquid in a tank. For example, in the tank, so we have what we call the direction of depth, that represented by H symbol. So this what I call the force diagram, free diagram represent what I call the pressure profile. When the value of H or depth increase, the pressure will also increase. Okay, for example, we have, let's say we have 0.2 and 0.1. So in terms of pressure at point 2 will be higher compared to pressure at point number 1. So let's say we have the depth difference that represented by delta Z. So we will have this relationship for the pressure difference, where the pressure difference delta P equal to P2 minus P1. So we need to put the higher pressure first minus the lower pressure, will be equal to rho, the density of the liquid or water, multiplied by gravitational acceleration G. Normally the value of G equal to what I call 9.81. Okay, meter per second square, multiplied by delta Z. So this is the basic relationship in terms of pressure difference. Okay, next about the fluid pressure for fluid at free surface of liquid. So we want to have a relationship in terms of pressure or pressure difference at free surface for liquid. Pressure at free surface of liquid. Okay, the fluid pressure is the atmospheric pressure, and the pressure at the depth from the free surface. So we use the same schematic diagram. So we have free surface of fluid. Let's say we have point number 2 and point number 1 is located at the free surface of the liquid. Okay, so now P1 will be equal to P atmospheric or atmospheric pressure, and we have the call the depth or the depth difference between point number 2 and also point number 1, that represented by H. So the pressure of point number 2 will be P2 equal to P ATM plus rho GH. Okay, so at the beginning we have the temperature difference between these 2 points, P2 minus P1 equal to rho GH. Okay, and P for the liquid at specific point that have free surface liquid, so equal to P2 equal to P1 plus rho GH. As we know, P1 equal to P ATM, so the pressure at state number 2 or point number 2 will be P equal to P ATM plus rho GH. And we know that rho GH actually is the gauge pressure, so we can substitute into the equation. So we'll have the final equation P equal to P ATM plus P gauge. Okay, next about the variation of pressure of gases. For gases, okay, variation of pressure with height is negligible for gases, which means, let's say we have a room, so inside the room we have gases or air as our gas, and the blue arrow represent the height inside the room. So let's say state number 1, the pressure of air at the top is 1 atm. The lowest point in the room, P2, refer to the the air pressure at the bottom. We can see that the value is 1.006 atm. Okay, this is for gas or for air. So we can see that the air pressure, we can conclude that air pressure is more or less equal to 1 atm. So that's why we have the statement where the variation of pressure with height is negligible for gases. So P2 more or less equal to P1 equal to P air equal to P gas. Okay, the last one is about the liquid pressure on a horizontal plane. Okay, so the liquid pressure for the same density of fluid is the same at all points on a horizontal plane. Okay, for example, if you look at this schematic diagram, okay, so we have free surface fluid. The blue color fluid is let's say water, and the red color fluid is what I call the fluid with higher density. So in this schematic diagram, we have two different fluid with different density. Okay, so we have what I call the depth that represented by H. So we just draw the horizontal plane. Okay, for the same liquid with the same density, all the point on the same plane will have the same pressure, which is referred to the point A, point B, point C, and also point D. Okay, so PA equal to PB equal to PC equal to PD. Okay, same goes to if we create a new horizontal line at the second type of fluid with different density, that refer to point E and also point F. So PE equal to PF because the point is at the same horizontal plane for the same density of fluid. However, if you compare to the point, the pressure at the, for the point for the blue fluid compared to the red fluid, so PC is not equal to PE, and also PD is not equal to PF. First, the density is not the same. The second one is the horizontal plane also not the same. Okay, so from this concept, we'll have new we will have new law that consider this kind of characteristic that we call Pascal law. So this law mentioned that the pressure applied to a confined fluid increase the pressure throughout by the same amount. Okay, the pressure applied to the confined fluid increases the pressure throughout by the same amount. Okay, in order to explain the statement, let's say we have this kind of system. We have two piston, a smaller piston and also bigger system, and we will use the hydraulic oil. So for this case, in terms of horizontal plane, we have the same horizontal plane, so that the pressure of the hydraulic oil at the same horizontal plane is the same. So we have the cross section area for piston, smaller piston, and the A2 represent the cross section area for the bigger piston. So P1 based on the liquid pressure on a horizontal plane concept, so P1 equal to P2 A2 bigger than A1. So let's say you want to lift what I call very heavy stone. So we know that the force equal to pressure multiplied by cross-section area. Okay, so F1, when we apply a force to the smaller piston, the value will be P1 multiplied by A1. So we'll get higher value of force that exert to the heavy stone, which is F2 equal to P2 multiplied by A2, where F2 higher than or higher than F2 higher than F1. So the what I call the Pascal law that implement the concept of liquid pressure on a horizontal plane. Okay, now we want to look at the meaning or the definition of states, processes, and also cycles in thermodynamic. Okay, the meaning of states is a set of properties that completely describe the condition. Okay, for example, we have the piston cylinder device. So this considered as state number 1, where we have numbers of properties such as a mass equal to 2 kg, T temperature 35 degrees Celsius, and also the volume 2.5 meter cubic. Okay, so because this state is considered as state number 1, so the properties we will state as M1, T1, and also V1. Okay, let's say we consider another state, which is state number 2. So we'll have different properties where we have M2. Because this one is considered as closed system, we have same mass M2 equal to 2 kg, same as state number 1. T2 40 degrees Celsius and V2 equal to 1.5 meter cubic due to the compression. Okay, now if you want to describe the state on the PV diagram or the diagram, so also we need to consider the cylinder piston device as shown in the schematic diagram. So let's say at the initial position of the piston, so the red color area represent our system, because we select what I call the boundary of system that represented by the red color area. Okay, the position of the piston at the initial state we consider as state number 1. Okay, we just put a point that state for state number 1 that represent the state number 1. Okay, so this state number 1 also we can refer as the initial state. Okay, so next the piston will move inward to compress the substance inside the cylinder, and then we will have the second state or state number 2. Okay, after the piston compress the substance inside the cylinder, okay, the size of the volume will reduce, so we have the second state or state number 2 represented by 0.2. Okay, so this is how we describe the state on the PV diagram, pressure volume diagram. Okay, for state number 2 also we consider as the final state for the process. Okay, so the movement of the piston will continue. Okay, so the state of balance we call equilibrium. So there are few types of equilibrium for the states. First, we have chemical equilibrium, where we have in the process we have no chemical reaction occur. The second one, we have phase equilibrium, where for different state we have same phase mass. Okay, the third one, we have the mechanical equilibriums. For different states we have same pressure. For example, we have state number 1, initial state, where we have two container separated with specific valve. First container we have nitrogen with 100 kilopascal, and the other one we have oxygen at 200 kilopascal. And then for the final state, when we open the valve, the gas, nitrogen gas and also oxygen combine, okay, will enter the nitrogen container, and also the nitrogen will enter the oxygen container. So at a certain period of time, because we already opened the valve, the pressure will be the same, okay, 150 kilopascal and also 150 kilopascal for both. Okay, so this state we consider as state number 2, which is the final state. Because the pressure is the same, we consider as this type of equilibrium as the mechanical equilibrium. Okay, so the example, the state 2 for this example is considered as the equilibrium state. The last one, we have thermal equilibrium, where we have the same temperature as we mentioned before when we discussed about the temperature. So we have two type of metal with different temperature. So we consider this as initial state or state number 1, where the iron temperature at 150 degrees Celsius and the copper temperature is at 30 degrees Celsius. So we will have heat transfer process, and at the end the temperature will be the same for both iron and also the copper for the final state, for state number 2. So at this condition, we consider the state number 2 as equilibrium state, and the type of equilibrium is the thermal equilibrium. Okay, so these are different type of equilibrium for the thermodynamic system. Okay, how about the process? What the meaning of the process? So the process actually is any change that a system undergoes from one equilibrium state to another. Okay, so if you want to describe in the PV diagram, first we need to know what the meaning of the path. So a path is a series of states through which a system passes during a process. So the green line represent the process path. Okay, so the line describe the process start from state number 1 to state number 2. And how about the cycle? The cycle means a system that is returned to its initial state at the end of the process. So from state number 1 to state number 2, from state number 2 to state number 1. So both process we consider as a complete cycle of thermodynamics. Okay, from state number 1, initial state to final state, and then from final state to the initial state. So now we have a complete cycle. Okay, under the process, we have few type of process. First, we need to know about the quasi-equilibriums. Before that, we need to know the actual process, where the actual process actually is non-quasi-equilibrium, where in terms of what I call process, the process will have insufficient time for equilibrium because the movement of the system very fast action. Okay, for example, we just take the piston cylinder device. So in actual, for example, in the engine, the piston move very fast, so the particle or the molecule of the substance inside the cylinder, we don't have much time to distribute evenly in the cylinder. So we will have that the particle or the molecule that very close to the piston will have insufficient time to distribute evenly in the cylinder. So we will have this kind of arrangement of the particle and also molecule inside the cylinder. So for this case, for different point in the cylinder, we will have different properties, such as, for example, different density of the substance. So the density of the substance that very close to the piston will be slightly higher compared to the the area that far from the piston. Okay, so the quasi-equilibrium actually the idealized process, where we consider sufficient time for equilibrium, where we assume that the piston move very slow, so that the particle or the molecule inside the cylinder will have enough time to distribute evenly in the cylinder. Okay, so that what's the meaning of quasi-equilibrium, and the difference between non-quasi-equilibrium and also the quasi-equilibrium. Okay, so and also we have the process involved with constant properties, and we will go through the different type of ISO process, which is there are a few type of ISO process. First, we have isothermal, which mean the process involved with constant temperature. Isobaric, the process involved with constant pressure. Isochloric is the process involved with constant volume. Okay, so the last one, the type of process that we need to know is the steady flow process. So the steady flow process is referred to the a process during which a fluid flow through a control volume. This control volume referred to the open system. Steadily, which is referred to the steadily means no change with time. Okay, the properties will not change with time. So the fluid properties can change from point to point in control volume, but remain the same during the entire process. Okay, so these are few definition of few characteristic to identify or to characterize the steady flow process. Okay.